Alright, today we're going to be expanding polynomials using binomial theorem. The first thing we need to do is look at Pascal's triangle. Pascal's triangle is derived by the binomials being expanded, and so if I do 1 and 1, that's my first row. My next row is going to be a 1, a 2, and a 1, 3, 3, 1, 1, 4, 6, 4, 1. It always begins with 1 and ends with 1. If you notice, we're adding the numbers that are above it. So 1 and 4 give me 5, 4 and 6 give me 10, 6 and 4 give me 10, 4 and 1 give me 5, and then I end with a 1. Okay, so here, this is going to be row 0, and it has 1 term. This is row 1, and it has 2 terms. This is row 2, and it has 3 terms. Row 3 has 4 terms. Row 4 has 5 terms. 1, 2, 3, 4, 5. And if you ever get stuck in trying to figure out which row you're on, you can always look at the second term, and it will tell you which row you're on. So this is row 5. It has 6 terms. Now the importance of this is when I am doing it, if I have something that I know belongs in the 5th row, I know I should have one more term than that. So row 13 should actually have 14 terms, and something that has 13 terms should be in row 12. Now this is how it's related to polynomials. A plus b raised to a power of 0 gives me 1, because anything raised to a power of 0 equals 1. Okay? A plus b raised to the first power is going to give me just a plus b. If you notice, the coefficients in front of a is 1, the coefficient in front of b is 1. Now over here, check out your terms, 1 and 1, and I'm going to underline those for you. A plus b raised to the second power, if I was to box or FOIL it out, I should get 1 a squared plus 2 ab plus 1 b squared. And again, my coefficients are coming from Pascal's triangle. A plus b to the third is going to give me 1 a to the third plus 3 a squared b plus 3 a b squared plus 1 b to the third. And again, the coefficients are coming from Pascal's triangle. The other connection I wanted you to make is as I am adding these, my a's are decreasing and my b's are decreasing coming this way. So we'll do this one by following some steps. So a plus b to the 4th. We're going to use the following coefficients: 1, 4, 6, 4, and a 1. So step 1, get coefficients from Pascal's triangle. Okay, then this is going to be a to the 4th because it's the 4th power. My a's are going to decrease, so this is going to be a to the 3rd, a squared, and 1a. So what I did was I counted down my a's starting with my exponent. Excuse me, my exponent. So we went that direction with our a's. Okay, now we're going to do our b's. B's are going to start down here. So this is b to the fourth, b to the third, b squared, b to the first. So the third thing I did, count down our b's, starting with exponents. And we're going to go in the opposite direction. I'm going to throw in a plus sign in between each coefficient. Okay? So that leads me to expanding binomials. Now we're going to apply it to two examples. The first example that we're going to use is we're going to do a plus 3, and we're going to cube it. So to do that, I'm going to go ahead and write an a plus b to the third, since we've already done it up here. Now remember, we got our coefficients from the above. We're going to go to row 3 and use 1, 3, 3, and 1. We also know that this should be a to the third, a squared, b, or excuse me, a, sorry. Then we're going to start with our b's, b to the third, b squared, and a b, and put in plus signs in between each of our coefficients. Now, what is above a? Well, the letter a. So that doesn't change any of our a terms. So this is 1a to the third plus 3a squared plus 3a, and then plus 1. What's above our b though? Our b value is 3. So wherever I saw a b, I'm going to put the number 3. So our b value here is 3, and I'm going to raise it to the first power. And then my b value here is squared, so I'm going to square 2. And my b value down here is to the third. Now I have to do the math. So my answer is going to be 1a to the third plus, this is multiplication, so this is 3 to the first, which is 3, times 3, which is 9, and then we bring down the a squared. So I basically took these two and I multiplied them to get to my 9. Bring down the plus sign. You have 3 squared, which is 9, times 3 gives me 27. And then I bring down the a. So again, I took these two to get my 27. And then the last term is 1 times 3 to the third. 3 to the third is 27, times the 1 gives me an answer of 27. So I've expanded by binomial. Or excuse me, in this case, the binomial was expanded to the third power. I have 4 terms, and so therefore I'm good to go. Okay, let's do one with the minus sign, because I want you to notice this was a plus sign and all of our signs in between were pluses. The next one I'm going to do is a minus sign. So c minus 4, and we're going to raise it to the fourth power. Let's change that. Let's change this to c minus 2. That makes our numbers just a little bit easier to work with. Again, I'm going to line this up and do a plus b to the fourth, because that's what I was familiar with when I did my Pascal's triangle up here. So my coefficients from row 4 are 1, 4, 6, 4, and 1. So 1, 4, 6, 4, and 1. Okay. Now I'm going to put in my a's. So this should be a to the fourth because of the exponent, a to the third, a squared, a, Then I'm going to work with my b's and go down with my b's. So this is b to the fourth plus b to the third, b squared, and b. So everything's got a plus sign in between it at the moment. Now, the step that I did over here that I left out, step 4, was we substituted our a's and b's for what's in the problem. What that means is wherever I see an A, I'm going to replace it with what's above A. So I now have 1. A is C, so I'm going to replace it with C, and it's C to the fourth. Bring down the plus sign. Then we have the 4. A is C again, so this is C to the third. But my B value this time, don't forget the negative, is negative 2. So this is times negative 2. Then we have 6. A again is C, so this is C squared. B is negative 2, so this is negative 2 squared. Bring down the plus sign. And the 4. A is C, so this is just the letter C. B is negative 2, so this is negative 2 cubed. And then our last term is going to be 1, and it's going to be B, which was negative 2, and we're going to raise it to the fourth power. Now we're ready just to do the math. So, nothing to be done to the first term, so C to the fourth. Here, we've got to look at 4 times negative 2, which gives me negative 8 C to the third. Then I have to look at 6 and the negative 2 squared. Negative 2 squared is positive 4 times the 6 gives me positive 24c squared. Then we're going to look at the next term, 4 and then the negative 2 cubed. Negative 2 cubed is negative 8. Negative 8 times 4 is negative 32. Bring down your c. And then our last term is going to be plus, because negative 2 times negative 2 times negative 2 times negative 2 is going to give me positive 16. So if I have a binomial expanded and it's positive, then all my signs are going to match. So all signs, are positive. But here I had subtraction. So all signs alternated. Now, what's really cool about this is by knowing all this information, I'm able to apply it to standardized questions. If I have a problem that says a plus 3 raised to the third, I know it should have 4 terms. 1, 2, 3, 4. So I could eliminate my choices that do not have 4 terms. I could also eliminate my choices that do not have all plus signs, knowing that there's a plus in the middle. I could then, once I've started to eliminate problems, I can make sure that my first term was cubed and my last term is cubed. By doing those 3 things, you probably have eliminated 3 out of the 4 answers. Same thing for this one, c minus 2 to the fourth. I know that it should have 5 terms, 1, 2, 3, 4, 5. Eliminate the problems that don't have 5 terms. Then I check and make sure that because of the subtraction that I have alternating signs. If I haven't eliminated any more after that, then I should look to see if I have c to the fourth as my first term and negative 2 raised to the fourth power as my last term. Again, those 3 things are really helpful when you're doing standardized test questions. I hope this helped, and I hope you have good luck on your homework.